Okay, so whenever we record a Zoom, you'll hear that recording in progress, but I think you also get a pop-up letting you know that the class is being recorded. So and again, the whole purpose of that is if you miss part or whole of the class, you can catch up on it. And after each class, I'll send out an email. If we watch any videos together, I'll send you links to those videos again, and I'll send you a link to the recording. And then sometimes we grab screenshots that are useful. I put those in the email. So after each class, you'll get an email from me. Okay, so let's get started. Oh, any questions first about anything about the course at all? I mean, I can't answer all the questions about the Google part, but I can try. Any questions to start off with? Okay. Well, good morning, everyone. And here we go. Okay. So right now you should be seeing a screen that I'm sharing that says course norms. And again, sometimes you may have to move things around a bit. Ideally, you'll be able to see both the slides I'm sharing and the video panel, so you see each other. So try to, if you can, manipulate your windows on your computer so that it's, you have the best view possible. And if you want to just see the slide, that's fine. But okay. So anyone not see the course norms slide? Okay, great. So yesterday we talked about the learner expectations. Those are kind of the rules for what you should follow. But the rules come from above, right? They come from goodwill, from us to you, from top down. But there's another thing that's really important too in class, which are class norms. And the norms come from you, bottom up. And the norms basically are, how do you want us to interact? How do you want your fellow classmates to behave, interact in class? Can somebody give me an example if you know what I'm talking about, just so for those who are not clear, maybe get a better idea? What might be a class norm for how you want people to behave, act, engage?
Respectful, professional.
There you go. Okay,
Courteous.
good. Excellent. Okay, good. So respectful, courteous, and I'm sorry, Tamara?
Professional, treated as a work
Professional.
environment.
Yeah, that's my short-term memory. Okay, yeah. So there's one, and let's phrase it as a sentence or as a bullet point. So students will behave respectfully, professionally, and courteous at all times, something like that. So the norms are, how do you want to interact with each other? It's not one of the rules, because we already know the rules, show up on time, do your own work, et cetera, et cetera. But the norms are like example of what Tamara just said. So what I'm going to do now is I'm going to put you in breakout rooms, and basically, thank you, Andrews, and remain active and engaged is another one. Good. I'm going to put you in breakout rooms so that you're going to be working with just a smaller group of students. In your group, see if you can come up with 1, 2, at most 3 more norms, however you feel, like what Tamara shared or what Andrew shared in the chat. And then I'll bring you together and we'll go around group by group. Each group will share one. We keep going around so we kind of share everything. Some of you may have similar ones, and then we'll work on the wording. The whole point is to come up with a list of norms from you, how you want the class to go. That's important. Does anyone have any questions about what we're doing? Okay, and then I'll enter the norms for you when you come back. Oh, one more thing before I take questions. Each group, once you get together, introduce yourself, say hi, and then choose someone who's going to take the notes for your group, so that when we get back together, that person will share the 1, 2, 3 norms or whatever that you came up with. If students come in late after you're already in the breakout rooms, I will move them to a breakout room. So if you notice a new student pop into your room, just tell them what's going on and bring them into the discussion. Okay, now any questions?
No.
Good. Okay, so what I'm going to do is I'm going to create the breakout rooms. Let's see, how many students do we have? 18, 17. So let me do 4 breakout rooms. And I'm going to have Zoom create these automatically because I don't know you that well yet. I'm just going to have Zoom do it. So once I click on open all rooms, you're going to get a pop-up. It's going to tell you which room you're going into, and then you'll be in that room with 3 or 4 students. Again, the task at hand is a simple one. Come up with a 1, 2, or 3 norms. More if you want, fewer if you don't have any. That's fine. At least one that you're going to share on how you would like everyone to interact. We already have one from tomorrow, one from Andrews. So, go with that theme. So it shouldn't duplicate any of the rules I gave you, like, arrive on time. We already know that's a rule. These are your norms. Who has questions before I open the rooms? We're all good? Okay, so go into your breakout. Yeah, question? Laura?
Um,
Oh,
yeah, not a
Francesca.
question, but I saw two people they think the class starts tomorrow, and
Yeah, I don't,
the
yeah,
link is not linked. I forwarded to one person,
thank you.
but
Y-
um the
Yeah,
link that's being sent out, that it's a confusion. And I just wanted to let you know.
okay, thanks. Yeah, Mr. Akins noticed that and he got back to that one student he emailed. I'm not sure where that confusion came from. It was always going to be Monday the 29th, so I'm not sure. I apologize if anyone gave out the wrong information. We always start on a Monday unless a Monday's a holiday, not a Wednesday or whenever they thought. Yeah. But thanks, Francesca. Yes, Jeanette?
Hi, yes. I also was told that everything started for tomorrow, and I just got off the phone with Francesca. She forwarded me the link for me to just pop into the class. I have
Okay.
no idea. I'm sorry. I'm sorry, everyone. I have no idea what's going on. I couldn't
Okay.
even get the link for yesterday's Zoom.
Okay, I apologize. The link was set out by Mr. Akins, and it's possible it went into your spam folder because your email didn't recognize it. But I apologize.
There was nothing in the spam folder.
Okay.
The link that came up, it was asking you to purchase extra files.
No, what he sent was a recording of the class, so that shouldn't have been. And I checked it; it seemed to work for me, so I'm not sure what the problem was there. I apologize.
Because Francesca also looked at it and she got the same thing, and I saw that there were 2 other students that had the same issue.
Okay.
So I don't know like what to do. Like how you were just talking about switching over to like Zoom, like for us to be separated in Zoom classes to do group work.
Right.
How do we do all of that, and also like for your classes?
Yeah. Give me 1 second, Jeanette. I am going to send you the email I have directly to you. If you could just check and make sure we haven't made a mistake.
Okay, bear with me just one moment. I just saw an
Okay.
email.
And then I'll answer that question. Okay. Any other questions?
Excuse me, I don't see what I've been assigned to. Where's that information?
I haven't opened it up yet because Jeanette had a question. So I
Okay,
haven't,
no problem.
yeah, I haven't clicked on open rooms yet, so that hasn't popped up. So let me just address it again. If anyone came a little late and didn't hear it. So just to reiterate, especially if you were out yesterday, and I apologize if there was miscommunication. So this is also for Matthew, who was out yesterday, and Jeanette, so my apologies. So there are 2 teachers. I'm Mr. T. I teach the ABE, which is the math and the reading. Mr. Akins is the Google IT teacher, and he teaches the Google IT. And the schedule varies Monday, Wednesday, Friday. You have Mr. Akins first. I close out the day. Tuesday and Thursday, you have me first. Mr. Akins closes out. You have me about 2 hours a day, Mr. Akins about 4. The majority of the time is with him because, again, the goal is to earn your Google certification and then get job placements. But my part is important too because we want to make sure everyone is up to speed on their math and their reading. Plus, we talk about other things. We talk about career choices and other things in my part of the class. So what I suggest you do, if you haven't, is to add our emails to your contacts. Let me just pull up Mr. Akins' email. So I'm going to put his in the chat so everyone make sure if you haven't yet, add it to your contacts. So when Mr. Akins emails you, it won't go into your spam folder. And I'm going to put mine in the chat as well. So again, I suggest you add both of us. Okay, need to make sure I did it right. Yeah. So any other questions before we get started? And
Yeah,
again,
I didn't see anything hit my spam or anything. There's nothing in there in my emails.
okay, so you didn't. So there should have been an email yesterday from Mr. Akins about the recording. And there was an email from me with the class schedule, and there was another email from Coursera with the Google IT course material. So you should have gotten 3. You didn't get any of those?
Coursera I received, and I've
Okay.
already registered. I received your email with the class schedules. Mr. Akins get one, that's the one that's problematic,
Oh,
and Francesca
okay.
emailed him with no
Okay.
response because she saw it too, that is opening up to a website to ask you to purchase extra files.
Right.
And
Okay.
that's it.
Okay. Let me open his email and see what's going on. 1 second. In fact, let me just pause the recording for a minute.
Department of Labor's, or you can click the one
Right.
that says for Goodwill. So
Mhm.
Oh, okay. I just did it straight
Yeah.
from the email because I
So-
have the Department of Labor one. I'm doing the digital marketing class on
Mm.
that one. So
right. So also, before I had stepped out, someone else had said that they had taken some of the course.
I think that was Tanisha. Tanisha, yeah.
So for you, depending on which courses that you did, you wouldn't have to do the ones that you've already completed. Unless you want to help us out in the class, that'd be tremendous. But I won't hold that to you. So we can talk separately to see like which ones that you
Okay, I
still
sent
needed
you
to do. Or
Okay, I sent you an email with my number in it.
okay. I mean, we can either talk on the
Oh, it's up to you.
Yeah, I can make a breakout room. Yeah.
Okay.
All right, cool. All right.
Okay, great. Okay, good.
Anyone else that didn't get the link for Coursera or having any issues? All right, so everybody good. All right, that's good. All right, awesome. Tanisha, I'm gonna make a breakout room for us. Give me 2 seconds.
No problem.
Okay. And I asked them again to enter your email and mine in their contacts. So hopefully it goes into their inbox and not lost somewhere in cyberspace.
Yeah, that's fine. Yep.
Okay.
Perfect.
Excuse me, Mr. Tupel, Mr. Akins, for the Goodwill or Jersey Coursera, for this class itself, is it just the IT fundamentals? Because I saw other courses, or is it all the courses on that list?
It's just the Google IT's support.
Yeah, that one.
Yeah, just that one. That's the one that I'm teaching.
Okay, because it was like
what you
5 other
do-
courses
Yeah.
listed.
That won't be taught by me. Now, if you wanted to go ahead and do that on your own, that's on you.
Oh, okay, so it's not taught by you because I went ahead and
yeah.
started already, so.
Yeah, like that UX design and like
That's
other
what I was talking about.
yeah,
Yes,
no,
other ones.
So we're
And
gonna in this class we're focusing on the Google IT support.
So those are just like additional recommendations if you want to do them.
Yeah, basically, I think.
Coursera,
Yeah,
guys, I'm
Coursera.
sorry. I'm a huge fan of
No, go ahead.
it's basically all the opportunities, like all the certifications you can actually take and put on your resume, and the more you have, the stronger your resume will be in that particular field. The UX design, that's when we are talking about like the further education, right? The further certification, because you need like, that's like the Flatiron School and General Assembly and those kind of like programs, boot camps. They cost like $15,000. So you guys, we're getting a discount.
So I mean, again, don't put the carriage before the horse. I think that's how this saying goes. So this is the Google IT support. class. This is like the English 101, math 101. So this is your first step into getting to those other
Introduction.
yeah, exactly.
Yeah, yeah.
Okie doke.
Plus, you're going to be very busy with this class. It's intense. There's a lot of work. So, I suggest that if you wanted to take other courses in Coursera, you wait till you finish this course.
And I'll be right back.
Yeah, otherwise it's going to be difficult juggling two things at once. Mr. Akins, do you know how long their Coursera is active for? No, he just left. He's in a breakout room. Okay, we'll ask him when he comes back. Okay, any other questions? Okay, so let me go back to course norms.
One last question.
Yeah, go
sorry,
ahead.
I didn't mean to interrupt.
No
'Cause
problem.
I'm hearing two different things. I'm hearing the class is 5 weeks, then I was hearing it's 6 weeks. So is
Right,
it like
it's-
just
Yeah, it's 5 weeks. However, depending on whether everyone finishes or not, we always plan for a 6th week. Sometimes students don't need it, and then sometimes there are a few people who, or some, or all, depends, who need a little extra time. And then for that last week is usually a little more one-on-one help finishing things up. So I would say plan for the full 6 weeks just in case you need it. That brings us out to the first week in September. I think September 6th. So it's all of August. August is almost here. And then like the first week in September. But plan for that 6 week just in case. But many students finish in 5 and they don't need that extra time. But we have that built in for those who need it. Good
understood?
question.
Thank you.
Yeah, good question. Okay. Okay. Okay, great. So what I'm going to do now, looking for my breakout room.
Oh, wait, and since he wasn't here yesterday, we may have only Monday through Thursday for class.
Right after I'm trying to find my breakout room.
That is not a problem.
Right. So I would say don't count on it this week at all, because really yesterday we didn't do anything, and today we're also kind of getting a slow start. But probably starting in week 2 or 3, as long as everyone's on track, as long as we're all moving, through the course at the right pace, then we often have some Fridays off. So I can't promise you, but it's nice to do that if we can get have that long weekend. Okay, here's the breakout rooms. Okay, so I have to. Oh, he's in a breakout room now. How do I do that? Okay. So I can't open the rooms because he's already in one. So let me wait till Mr. Akins is finished with Tanisha. And what I'll do now instead is jump into some math. And then after we do the first math lesson, we'll go back and we'll do the breakout rooms with course norms. Okay. So take all your ideas, your rich ideas that you had for norms, and just park them in the back of your brain for now. We'll come back to that in a little bit. Okay. Any other questions? Okay, this is great. And please always Tamara, I appreciate that, but I'd like everyone to work together in small teams. So what I would suggest you do is write down your ideas now, anyone who has them, so you don't forget them.
Yeah, I already did.
Yeah, just write them down because not everyone can park things in their brain and remember them. That's why I have these reminder cards for myself. But yeah, don't lose your ideas, but we'll come back to that. Okay.
I like your reminder cards.
Yeah. When I used to have a partner teacher, like Mr. Akins, but this was when we were teaching together, and one of the things that the partner I had was talking way too fast, and no one could follow him. So the card I would hold up for him was slow down, and then sometimes I would talk too softly, and he would hold up a card that says speak louder. So it's nice sometimes to have someone in the back of the room reminding you. Okay,
it is not easy facilitating. It is
no,
not.
it's not. No, but I love it.
I have to do it with teenagers.
Yeah.
And you think you prepare yourself, you memorize all the stuff, and they still look at you like you dumb.
Yeah. Yeah, listen, I taught high school for quite a number of years, so I know what you're talking
I had a
about.
group, I called them the Mean Girls. And I'm like, why am I scared of teenagers? Like, what's wrong with
Yeah.
me?
Well, and then the middle school is even worse. So, okay. Um, yeah, my favorite grade to teach was 10th grade because at that point, students are starting to realize that they're not the center of the world, that there's other things out there. So they're starting to have more,
Yeah.
complicated thinking and all that. It's fun. But yeah.
No, it
Okay,
is
so
fun. 10th grade is on point with that. You're on
yeah,
point with that age group. They
it's an
start to
amazing
become
change. Yeah.
sponges.
Yeah, it's amazing change. Okay. Okay, so let's look at our first math topic. And am I recording? I forget. Let's see. I am. Okay. So the first math topic is number sequences. And we're going to talk about two kinds of number sequences, and then we'll also talk a little bit about how that relates to IT. But the first type of number sequence, and again, for some of you, this is like, oh my God, I know this. And for others, like, oh, I haven't thought about this in years. And for others, oh, this is new. So I apologize if it's review for you, but just soak it in and then share your thoughts too. So an arithmetic sequence is the simplest kind of math sequence. It's made by adding the same value each time. So for example, and by the way, I'm sharing a screen that says arithmetic number sequences. So if you don't see that screen, let me know, and I'll give you a minute to try to find it. So an example like 1, 4, 7, 10, 13, 16, 19, 22, 25. That's an arithmetic sequence. And we know that because we're adding the same amount each time. There's a difference of 3. Let me use my annotation tools here. So, 1 to 4, you add 3, 4 to 7, 7 to 10, 10 to 13, etc. Okay. So this is an arithmetic sequence. And the pattern is you just keep adding 3 to the last number. Now there's a formula to find the nth term, meaning any term, and we're going to use that in a couple of minutes. So don't worry about memorizing that, but we'll talk about more of that during the video. Mr. Akins, I see you're back. Did you want to talk to the students at all?
Just if anybody need anything else, I'm here.
So if anyone's having any kind of issue and they feel they need a one-on-one with Mr. Akins, speak up now and we can put you in a breakout room together.
I need a one-on-one with Mr. Aiken.
You do, Alexia.
Thank you.
All right, give me 1 second.
Okay. Okay, great. Okay, so let's take a look at our first video. And again, like I said earlier, you may have missed it. Whenever we do watch a video, I'll put the link in the email I send out at the end of the day. Okay, so here we go.
Hey guys, welcome to this video on arithmetic sequences and their formulas.
Okay, so just to pause for a second, everyone should be able to see the video that says arithmetic sequences and hear the woman talking. Is there anyone who didn't see or hear that? Let me know and I'll wait for you to move some stuff around and get it working.
Everything's good. He's on my end.
Everything's good. Good. Okay, anyone have problems? Okay, let me let her continue. We'll get to know these. This is from Mometrics, and we'll get to know there's like 3 or 4 teachers that we use a lot, and you'll get to know them. I don't know their names, but we'll get to know them well because we use their videos. So let's continue with the video on arithmetic sequences.
Sequences typically have set patterns that enable us to predict what each term might be. A list of numbers ordered in a particular way is a sequence, and each individual number is referred to as a term. Understanding arithmetic sequences and how to identify them is a great way to develop critical thinking skills. Identifying how numbers relate to each other and what commonalities they have in a sequence can carry over into better critical thinking skills and other intellectual endeavors. An arithmetic sequence is a sequence or progression of numbers where the difference between each number is the same, or constant. For example, in this series 5, 12, 19, and 26, we can tell that this is an arithmetic sequence by subtracting each number from the number following it. So 5 minus 12 equals -7, 12 minus 19 equals -7, and 19 minus 26 equals -7. The difference is the same each time, therefore it is a constant. In other words, to tell whether or not it is an arithmetic sequence, we need to be able to see what is happening between each number, and whatever happens between the two needs to be the same thing that is happening between each consecutive number. Another way to write this arithmetic sequence is A plus D, A plus 2D, A plus 3D. The letter A represents the first term and the letter D represents the constant difference. So, looking back at our sequence of numbers, let's apply this. 5, 12, 19, 26. Using this method, let's plug in our numbers. We have 5 as our first term, and we know that the constant difference is 7. 5 plus 7, 5 plus 2 times 7, and 5 plus 3 times 7, which equals 5, 12, 19, and 26.
Okay, let me just go back to there. Okay, so it's really simple that for an arithmetic sequence, you have a starting number. Not all sequences start at 0 or 1. They can start at any number. This sequence starts at 5. And then you have a common difference, which means what number are you adding each time? What's the difference between each number and the one after it? So in this case, the common difference is 7. So the sequence can go on to infinity. You would just keep adding 7 forever. Any questions on that? Okay.
Equals 5, 12, 19, and 26. What if we wanted to find the 50th term in the sequence? Let's write an arithmetic sequence as a formula. X sub n equals A plus D times n minus 1. The reason n minus 1 is used is because D, the constant difference, is not applied to the very first term. Let's take a look at a new arithmetic sequence and using our new formula calculate a certain term. Look at this sequence. 9, 17, 25, 33, 41, 49, 57, 65, 73, 81. So, we're going to calculate the fourth term using our formula. We know that our first term is 9, so now we have to calculate this constant difference, which is 8. So we're looking for our fourth term, which is represented by x sub 4. A is our first term, which is 9, D is our constant difference, which is 8, and n represents the number sequence order, which in this case is 4. So let's plug in our numbers. X sub 4 equals 9 plus 8 times 4 minus 1.
Okay, let me pause here for a minute. Okay, so just to be clear, to see what's going on here. If I want to find, let's say the thousandth term in a sequence, what I could do is just keep adding. In this case, I'm adding 8 each time. And I would have to keep adding till I get to the 1000th term. And that is really inefficient, right? There's a shortcut to it. So if I want to find the 1000th term, it would be x sub 1000, then I would use this formula. Now, normally you wouldn't use this formula to find the fourth term. All I have to do to find the fourth term is add 8 4 times to 9, and I've gotten it. But this is just an example to show you, again, if you wanted to find a term that's higher. So the first one here is your A. That's your starting amount. So that's what does the sequence start with? And she's told us the sequence happens to start with 9. Again, it could start with anything. Now, what's the common difference is 8. So you're adding each, oops, let me just go back 1 second. Let me put the D up here. So the difference, the common difference means I am adding 8 each time. So 9 plus 8, 9 plus 2 times 8, 9 plus 2, etc. Now, what if I want to find the fourth term in the sequence? Then what I do is I take that number and I put it here, but I take minus 1 from it because we're not counting the first term. So to find the fourth term in the sequence, it's 9, which is our starting amount, plus the difference, 8, times 1 less than the number we're looking for, which would be 8 times 3, which is 9 plus 24, which then comes out to be 33. And again, I probably wouldn't use this just to find the fourth term because it's easy. 9 plus 8, 9 plus 16, and then 9 plus 24. And there it is. I don't need the formula for the fourth term, but if I wanted to find the 20th term, the 1000th term, then I'm going to use the formula. Okay, so I'm going to clear this and let her continue. But any questions about what this formula is and when you would use it? Okay, let me look. Good. Okay, let me let her continue.
Which equals 33. Now, typically, you wouldn't use the formula to calculate a term that is already listed, but rather to predict and calculate a term farther along the progression of numbers. So let's say we wanted to calculate the 1698th term of this arithmetic sequence. X sub 1698 equals 9 plus 8 times 1698 minus 1.
Okay, again, let me just identify what these are again. 9 was our starting number, the first number in the sequence. How do I know that? That's what she told us, right? 8 is our common difference. That's how much it goes up each time. How do I know that? That's what she told us. I'm looking for the 1698th term. So that goes inside the brackets, but we always subtract 1 from it. And then, so the 1698th term in the sequence would be 13,585. And that's something that I don't want to have to list 1698 numbers. I can do it quickly with this formula. Questions? Okay. And if let me know if I'm not giving you enough wait time. Like if I ask a question, sometimes I jump right in and I don't respect those who take 2 more seconds to think. So are there any questions? Okay, that's my wait time. And let me continue.
Which equals 13,585. I hope that this video was helpful. To check out more of our videos, be sure to subscribe to our channel. See you next time.
Okay. Okay, here we go. Okay, any questions about what you just saw on arithmetic sequences?
No.
Excuse me. Okay. Okay. So there's another kind of sequence, which is a geometric sequence. And remember, with arithmetic sequence, we add a number each time. Geometric sequence, we multiply. So for example, 1, 3, 9, 27, 81, 243. What are we multiplying by each time in that sequence? How do I get from 1 to 3?
3.
3, thanks, Cecile. Yeah, I'm multiplying by 3. Now, notice that geometric sequences grow very quickly. Arithmetic sequence kind of just pokes along, adding 8, adding 8, adding 8, something like that. This one, since you're multiplying, the numbers can grow much more quickly. Okay. And we're multiplying by 3. So let's try this one. First of all, is this a sequence? Now, for it to be a sequence, you have to either be adding the same number each time or multiplying by the same number each time. So what's happening here? Are we adding or multiplying?
You'll be adding.
We're adding.
Adding, good. And is it the same amount each time?
Yes.
Yeah.
Yes, it's number 5.
Good, we're adding 5. So, that's the first thing to check. Is it a sequence? Because I could just throw up a list of numbers that might not be a sequence. It is a sequence. And if you check, we're adding 5 each time. So what kind of sequence is that? Arithmetic. Yeah, very good. That's arithmetic. Yeah. Arithmetic is the noun. Arithmetic is the adjective, right?
It looks like
Arithmetic.
arithmetic, though. I'm not gonna lie.
Right. But again, English is weird where you can have words be nouns or verbs, but you pronounce them differently. Okay. And the same thing with nouns and adjectives. So my grandfather used to say the emphasis is on a different syllable, which is what he used to say.
Yeah.
When he was joking around. Okay. So let's see this one. So this sequence has a difference of 5. So we're adding 5 each time. So therefore it's a common difference. And yes, it's an arithmetic sequence. Okay. Questions on that one? Okay. Now, this is another arithmetic sequence. What's the common difference? Richard, go for it. Let's see, you unmuted?
It's multiplication. Oh, sorry.
Okay, yeah, that's okay. Richard, we couldn't really hear you. You need to talk closer to your mic or turn it up a bit. Okay, Tamara, what is it?
It's multiplication.
How do we get from 19 to 27? Are we adding or multiplying?
Adding.
Yeah, we're adding how much?
8.
We're adding 8. Yeah, we're adding 8. And then again here, we're adding 8. So here we're adding 8. So actually, this is an arithmetic sequence because we have a common difference and we're adding the same amount tomorrow in this one. So it's not geometric. We're not multiplying, we're adding, right? And how do you figure that out? It's just simple. Take the second number, subtract the first number, see what the difference is, right? Now, for this to be a sequence, it has to be consistent. So let's take the third number, subtract the second, and again, we have the same difference. So that's just a way to check. It's a constant common difference. It's the same each time. So yeah, this would be a good arithmetic sequence. Questions? Okay. And again, this sequence will poke along, adding 8 each time. Okay. Now, a common difference can also be negative, right? So we don't always have sequences that increase. We can have sequences that decrease. What's the common difference here? Yeah, -2. Richard, again, I barely heard you. See if there's a way you can just make it a little louder so we can hear you better. So what's happening is, perfect, that's much better, yeah. So Richard said the common difference here is a negative number, it's -2. So what we're doing is we're not adding 2 each time, we're subtracting 2. And then if we continued, we'd have 17, 15, 13, 11, etc. Eventually, what number would we reach if we keep just subtracting? What kind of number would we reach?
Negative,
Yeah.
-2, right?
Negative. Yeah, we would eventually go down to 9, 7, 5, 3, 1, and then -1.
Oh, negative.
-3. Yeah, right. Thanks, Andrews. Thanks everyone who said that. So sequences can increase and sequences can decrease. So you can also have a common difference that's negative. Any questions about that?
No.
Okay. Yeah. Okay. So let's take a look now at a video on geometric sequences. And we have a different guest teacher this time. Let me share that with you. Okay.
Hello, and welcome to this video on geometric sequences. Today we'll explore how to find a term in a geometric sequence using a formula. We'll also learn how to find the sum of a specific number of terms in a geometric sequence. Before we dive in, let's review a few things. First, a sequence is an ordered set of numbers with a pattern. The pattern helps us predict what each term might be. For example, 2, 4, 6, 8, and 10 are a sequence. A term is an individual expression or number in the sequence. A geometric sequence is a special type of sequence. Each term is a fixed multiple of the number that comes before it. For example, let's say my first number is 2, and I multiply 2 by 5 to get 10. Then I multiply 10 by 5 to get 50. I can multiply 50 by 5 to get 250, and so on.
Now, what she means by a fixed multiple, again, is that in a geometric sequence, you are always multiplying by the same amount. So just like in an arithmetic sequence, you're adding. In a geometric sequence, you have to be always multiplying by the same number. So this is a sequence where each number is multiplied by a fixed amount, which is 5, to get the next number.
2, 10, 50, 250. In geometric sequences, we use multiplication to find each subsequent term. The number we multiply by is called the common ratio. Each term gets multiplied by the common ratio, resulting in the next term in the sequence. In this geometric sequence, the common ratio is 5. To find any number in a given sequence, we can use the following formula. A sub n equals...
Okay, and we actually, this is more than we need to be able to predict. So I'm going to include the link to the video in the email I send you, and you're always welcome, of course, to watch the rest of the video. But I think for our purposes, just to know the difference between arithmetic and geometric is enough. But again, feel free to watch the video. Okay. So with a geometric sequence, we can start with any number. Doesn't have to be 1. So for example, 2, 6, 18. What's the common ratio here? What are we multiplying by?
3.
3.
Good. So each time we're multiplying by 3. And remember, it has to be the same thing each time. And what's the starting amount? The first number.
2.
2, yeah. So we have a starting amount of 2 and a common ratio of 3. Okay, so it's a geometric sequence. And notice again, geometric sequences grow very quickly. If you were to graph that on a graph, it wouldn't be a nice straight line like an arithmetic sequence that just goes up like a series of steps. It would be like a curve that jumps really fast, right? So if I were to graph it and we started at 2, 6, 18, like that, you'd have a line that jumps, that goes up very rapid. Okay. And we'll talk more about that when we start looking at algebra. Okay, good. So any questions on this before I move on? Okay, let's try this one. So what's the common ratio? So I'm already telling you it's geometric, right? If it's a ratio, it's geometric.
Everything is doubled.
Doubled, yeah. So this is one that doubles. So times 2, times 2, etc. times 2. And then what's the starting amount?
1.
It's a 1, yeah. So that way, you know, again, this is a sequence that does start at 1. And this is a sequence that doubles each time. So again, if we were to graph that, we would get that slope that rises up very quickly. Questions? Okay. So here we go. Okay. Oh, now in geometric, now remember with an arithmetic sequence, if you have a negative number, we saw that the sequence decreases, 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 and eventually will pass 0 and go negative. Now, with a geometric sequence, the common ratio can also be less than 1. What are we multiplying by here each time? 10 to get from 10 to 5, what are we multiplying by? Say it.
By -2.
Yeah, I heard someone said a half.
Is it -2? Oh, never
Did
mind.
you say dividing by 2?
No, I said -2.
No, it's not a negative, right? Because, for example, if we multiply 10 times negative 2, we would get negative 20, right? So that's not, yeah, that's not what we're seeing here, right? So it's a good guess, but it's not negative. Yeah, so there's 2 possibilities.
Divided by 2.
Yeah, well, yeah, so instead of dividing by 2, right? Instead of dividing by 2, we can flip that upside down and say we're multiplying. We're going to change division to multiplication, and we're multiplying what's called the reciprocal of 2, which is 2 upside down, which is a half, right? So dividing by 2 is the same as multiplying by a half. Dividing by 3 is the same as multiplying by a third. Those are called reciprocals. 2 upside down is a half, 3 upside down is a third. So usually, yeah, 0.5. Good. Thanks for adding that, Emmanuel. So we can say that the common ratio is a half, or we can say the common ratio is 0.5. So it's probably better to use decimals because all of these numbers are given in decimals. So if we multiply 5 times 0.5 or a half, either way, we get 2.5. Half of 2.5 is 1.25 or 1 1/4. Half of that is 0.625. Half of that is 0.3125. If we keep going, the numbers will get smaller and smaller and smaller, and they'll get closer and closer to 0. Will they ever reach 0? Here's an existential question. Will they ever?
No.
No, they'll get closer and closer. They'll approach 0. And someday if you want to learn calculus, it's all about those kinds of things where you're approaching numbers. But yeah, it's kind of boggles the mind that you'll never actually get to 0. You'll get smaller, smaller, smaller. You know the myth of Sisyphus? Does anyone know that myth? An old Greek myth. So he was given a punishment, and he had to roll a stone up to the top of a mountain. And each time he got it up there, it would roll halfway back. And then he would get up to the top again, and it would roll halfway back. So the problem with Sisyphus is that he's never going to reach the top of the mountain. It's just always going to roll back half the way. So this is kind of like that. Okay, any questions on this? Any questions about the relationship between 1/2 and 0.5? Anyone want me to show how we got that? How Emmanuel and others got from a half to 0.5? We're all good? So I don't know you that well yet, so I want to make sure. Ant-Man, okay. So Ant-Man never totally disappears, but he gets really small, right? I haven't seen that movie. Is it worth it?
If you want to be up to date with Marvel, yeah, I guess.
Okay. Yeah, I just watched The Flash over the weekend and really enjoyed that one. So,
Oh, so you're a DC guy.
not really. It's my younger son is really into the Marvel universe, and my older son is more into the DC universe. And I'm agnostic. I'll just watch anything if it's fun. I grew up reading Fantastic Four and Silver Surfer comics though when I was a kid. So I still have my Silver Surfer 1. Probably worth something. Okay. Okay. Enough about me, right? You don't need to know about Mr. T. Okay. Yeah. So you'll learn as I teach you more that I'm neurodivergent, and I'm kind of a nerd if you haven't guessed already. But yeah, I'm into comics and Star Trek and Star Wars and all that stuff. Okay. Okay. So I'm going to show you one more sequence. It's not geometric and it's not arithmetic. It's a really interesting one, and it's called the Fibonacci sequence. You don't really need to know this, but I think it's just interesting. So let's watch this. It's named after the mathematician who discovered it, Fibonacci. And let me show you this one. Okay, but I have to share the sound. Okay, and we'll take our break at 10:45 for 15 minutes, and then when the break's over at 11, Mr. Akins takes over. So just in case you're wondering, usually Tuesdays and Thursdays we'll break at 10:45, and then at 11 you'll have Mr. Akins. Okay, and then again there's an hour for lunch at noon, and then there's a second 15-minute break in the afternoon if we go that late. Depends on how late we go. Okay, so let's look at this Fibonacci sequence. And again, I'm sharing this just because I think it's cool.
If you look at nature, there are numbers, for example. So there are many flowers that have 3 petals like this, or 5 like this. Some of them may have 34 or 55. These numbers occur very often.
These may sound like random numbers, but they're all part of what is known as the Fibonacci sequence, a series of numbers developed by a 13th century mathematician.
You start with the numbers 1 and 1, and from that point on, you keep adding up the last 2 numbers. So 1 plus 1 is 2. Now 1 plus 2 is 3. 2 plus 3 is 5.
Okay, so again, yeah, you start with 1 and then another 1, and then to get the next number of the sequence, you just add the last 2 numbers together. So 1 and 1 is 2, 2 and 1 is 3, 3 and 2 is 5, and then you just keep going.
3 plus 5 is 8, and you keep going like this. 5 plus 8.
Today, hundreds of years later, this seemingly arbitrary progression of numbers fascinates many, who see in it clues to everything from human beauty to the stock market. While most of those claims remain unproven, it is curious how evolution seems to favor these numbers.
And as it turns out, this sequence appears quite frequently in nature.
Fibonacci numbers show up in petal counts, especially of daisies. But that's just a start.
Statistically, the Fibonacci numbers do appear a lot in botany. For instance, if you look at the bottom of a pine cone, you will see often spirals in their scales. You end up counting those spirals. You will usually find a Fibonacci number, and then you will count the spirals going in the other direction, and you will find an adjacent Fibonacci number.
The same is true of the seeds on a sunflower head. 2 sets of spirals, and if you count the spirals in each direction, both are Fibonacci numbers. While there are some theories explaining the Fibonacci botany connection, it still raises some intriguing questions.
So, do plants know math? The short answer to that is no. They don't need to know math. In a very simple geometric way, they set up a little machine that creates the Fibonacci sequence in many cases.
The mysterious...
Okay, so I'm going to pause there. I'll include the video in in the email I sent if you want to watch the rest of it. But again, I included that because I think it's kind of cool that these sequences occur in nature all around us. So, next time, if you're looking at daisies or black-eyed Susan or any kind of flower like that, you can actually count the petals and see. You'll probably find the Fibonacci. Why is this? No one really knows, but it's there in nature, and something in the genetics of flowers, certain flowers, create these patterns, and then the pine cones too. Any questions on that?
It's almost, well, it's not exactly the same, but it's sort of like the whole priority principle. So known as the 80-20, or like a variation of.
Yeah, tell us more, Emmanuel.
And there was a Italian, what was he? I think he was a mathematician. I forgot what century. It was either 18th, 17th century. He observed an orchard that 20% of the fruit producing plants of the orchard gave like 80% of the produce that was created. And he discovered that principle and almost fits in every area of life. So let's say you have a company that has 100 workers. You have 20 workers usually that do like 80% of the output of the company, and it applies across the board.
Wow. That's fascinating. I've never heard that. Yeah.
Oh, really? I thought you knew about the Pareto principle.
No, that's new to me. Thanks for sharing.
AKA the 80-20 rule. Sometimes it's variation. Sometimes it's like 70-30. Sometimes it's 90-10, but usually you could take anything, and the 80-20 rule applies to almost every area of life.
Well, having been teaching for 40 years, I can tell you that I do see that often in teams I've worked with where a handful of people are doing most of the work. Yeah.
There you go. It's usually going to be 20%. Sometimes it's 30. Sometimes it's less.
Right.
Sometimes it's 90-10. When you got 10%.
Right. Cool. And you know what
output.
There's always going to at least be one person that is like.
You don't want to say it?
Is that what that means?
Yeah. And
sort of like that.
Yeah.
It's similar to the Fibonacci. It just seems to apply across everything. Like I said, it's usually 80-20. You could take any scenario and it almost plays out in every situation.
Unfortunately, it does sound suspiciously like something else, but in all the years I've worked, it is exactly what it is, because that is exactly how it happens. Some people fly by.
Yeah.
And some people be like, if we all fly by.
But you know what the reward is for doing most of the work? What's the reward? They give you more work to do, right? So
yes, they do.
They do.
And you burn out, get stressed, and
So that's really important in your careers, to make sure that you balance work and life. Because I've had some directors who really respect that and understand that you're a whole person with a family and you have an outside life, and they respect that, and you need time off sometimes. And I've had other directors that just treat everyone like robots, and okay, Francesca, so I understand. And I've left a couple of jobs because of that, because I've had toxic directors who just, I don't know what they think, they're gonna squeeze you dry. So that's something, it's like when you're interviewing, to talk about the culture. And if someone is, and the person you're interviewing says, "Oh, well, we're all team players, and we do whatever it takes, and we stay late," and those are red flags.
Mentiroso.
Yeah.
Usually when they're really, really, really excited and they tell you that all the right things, it's the same thing as if you don't come to the table correctly and you tell them all the right things. It's the same thing. The same way we can lie on an interview, they can lie to you. Please know that you are a commodity. You are not, like, just because you go on an interview doesn't mean that it's a favor for a favor. It's not.
Right. Right. Yeah. The thing important. Thank you, Francesca. The thing about interviews that's important. Yeah. The important thing to know is that you're interviewing them as much as they're interviewing you, and you should treat it like a business conversation. And then, as much as possible, if you can look up the company online and reach out to people who work there and ask them, what's it like, that can give you some insight too. And I've had some great directors who, they're just a joy to work for. Like this current job, it's a fantastic team. Everyone's in it for the same purpose. And then I've had other jobs where I've had to leave just because, no, I can't do that. I'm not going to I'm not going to kill myself. So anyway, let's go to the Fibonacci joke. It says, what did you think of my new Fibonacci joke? It was as bad as your previous 2 Fibonacci jokes combined. Okay, little humor. I don't know, if you got it or not, but okay. So why are we delving into sequences at all? Because sequences are important in programming and computers. The communication that the computer uses is referred to as binary. Now, can everyone see the slide that says how this relates to technology training? Anyone not see it?
Yes, I can see it.
Yes,
Okay,
I see
good.
it.
Okay, good. I always want to make sure. If I ask, anyone not see it, then I want to give that person time to just move some windows around. Okay, so the computers use binary system, also known as the base 2 numeral system. That means that computers only talk in ones and zeros. They can only count up to 1, 0 or 1. In computing terms, each of those is called a bit. So a bit can either be 0 or 1. Those are the only 2 values a bit can have. But then what computers do is we group those bits into groups of 8 called octets or bytes, B-Y-T-E. And each byte because we have basically 2 to the 8th, that gives us 256 possible values for the base 2 system if we have groups of 8. So that way, for the 256 possible bytes in a computer, they all stand for different numbers, letters, etc. So for example, here is 1, 2, 3, 4, 5, 6, 7, 8 positions. And let's say that this sequence that we're working with, let's say, is okay, 0, 1, 0, 0, 1, 0, 1, 0, something like that. That would be a tip, that would be what a byte looks like. We're saying the first bit is off, the second bit is on, this one's off, this one's on, off, off, on, off, right? So you can have, depending on what zeros and ones you have, there are 256 possible combinations. It's 2 to the 8th, which is 2 times 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 2, which is 256 possible combinations. And those then can stand for all the letters, numbers, and symbols that you use. And by grouping those together, the computers can translate anything. So when you're typing on your computer and you're typing hello, the computer in the background is changing HELLO to a series of 8 bytes, each byte having a series of zeros and ones, and interpreting it that way. When the computer is sending you back something, it's taking its binary information and turning it back to digital math, letters and numbers. So the computer is always doing that in the background. Any questions on that? We're going to spend a lot more time with binary math, but any questions on that? Okay, so a bit is either 0 or 1. 8 bits together is a byte, also called an octet, and that can stand for numbers, letters, characters, etc. Okay, and let's watch. I think I'm going to skip this slide. Okay, so what I'd like to do now is let's go back to the norms. Right, no one's in any breakout rooms now, are they? Let me check. No. Okay, so let's go back to the norm slide. Go back. There we go. Okay, so what I'm going to do is create 4 rooms. How many are we? I'll create 4 rooms. Okay, and I'm going to assign people automatically. Okay, so again, I'm not sure, some of you may have missed it before. What I'm going to do now, when I click on open rooms, you're going to get a pop-up on your screen that will, you'll click on it and you'll go into a smaller room here in Zoom with 3 or 4 students. When you're in that room, just talk about what other norms you want to see. We had a couple that were shared before, being respectful and a few others. So just come up with a small list. 1, 2, 3 is fine. Then I'll pull you back together after maybe 15 minutes, and then we'll share. So make sure that, introduce yourselves to each other. You want to try to start to get to know each other. And I'll probably, when I create breakout rooms, the first few times, just do it randomly to try to get you to interact with as many fellow students as possible until I get to know you better. And then I might put you in rooms more intentionally. So get into your room, say hi to everyone, pick someone who's going to be your recorder. So when we come back together, that person will share the norms you came up with, and then I'll enter them in a list and I can email that to you when you're done. Are there any questions about the task? Okay. No? The other thing too, if you can, when you're in your breakout room, try to turn your webcam on. It really helps to get to know each other when you can see each other. I want to thank Redborn and Jose and Brandon and Samantha for having their webcams on. It really helps me as your teacher too, to get to know you, but it helps each other to get to know each other. Any questions before I open the rooms? Oh, one thing, when you're in your room at the bottom of the screen, there is one of the buttons says shout out for help, something like that. If you need me to come into your room at any time, just click on that. I'll get a message, come into room 2 or something like that. And I'll be there in a second. Okay, I'm going to open the rooms now. Any final questions before we do that? Okay, so about 15 minutes and we'll come back together and share.